All right, so to check and see whether that's a factor, you use synthetic division. -2, 4. What do we got there? -4, 9, 0. -2 times 2 is -4. We do get a 0. 0 times 2 is 2. No, it is not. It is 0. It is -4, -8, and 1. But what piece of information do we get from that? Okay, that f of 2 equals 1. So f of 2 equals 1. So at least we know that, and that might come into play later. All right, so we know that. All right, what we need to do today is talk about finding the zeros of a polynomial. We talked about it a little bit, but you've never just had a full-fledged problem where you had to find everything. And that's kind of where we need to get to. And eventually, hopefully, this will lead to the rational zeros theorem. I don't have guided notes for you today because there's not a lot. There is one definition that we need to get down in a minute. But first, all right, if x equals 2 is the root of that function, let's find all the rational zeros. Just kind of a reminder, what does rational mean? Rational versus irrational, because I think that'll come up later in terms of numbers. So we got rational and we got irrational. All right, for that one. Do you remember on those? Peyton, any idea?
Is it like an irrational number would be like a square root?
An irrational number would be like a square root. Square root of 2. Square root of 10. Anything we don't know the square root of. Rational numbers, anything it can be written as a fraction or a terminating decimal, like 2/3, 3.4. Okay, anything on those lines. And then all your whole numbers, your positive and negative integers also fall into there. All right, so if x equals 2, find all the rational zeros. What's the first thing we do for this case here? Cooper, what do you think? What do we do there?
Oh, synthetic division.
Synthetic division. So I'm telling you, x equals 2 is the root, so we do synthetic division. But what do we put in the box?
You put -2 in the box?
That's good. It's x minus.
Positive 2 in the box.
Put +2 in the box. All right, so do synthetic division. All right, put 2, see what you get. Okay, see what you get. Now, if it is a root, what should our remainder be? Okay, you remember that, Adam?
0.
0. Okay, if you don't get 0, then I lied to you. I told you something wrong. All right, we get a remainder of 0. How many total roots can there be? Okay, let me just for the original function. So you get x cubed. All right, how many total roots can there be? Do we remember that part? Tony?
3.
There can be 3. So x cubed we hit 3 times. So we got one of them. All right, so now f of x, since 2 is a root, that means x minus 2 is a factor. And x minus 2 times what? Okay, what do we multiply it by to get back the original one? Okay, remember that is where we multiply it by our answer here. So that is now x squared minus 2x minus 3. All right, what do I do to find the other roots? Okay, don't make it hard. Okay, just think, okay, factor. Okay, I got x squared minus 2x minus 3. Factor, so f of x equals x minus 2 times, what is that, x minus 3 times x plus 1. So my zeros are, what do I got? I got 2, I got 3, and I got -1. All right, just go ahead and just draw a rough sketch. Just real quick. Just draw it out. And then actually go ahead and graph it on your calculator. We're going to use that here in a little bit. Graph it on your calculator as well. All right, so when I'm sketching this out, we said it hits at -1, it hits at 2, and it hits at 3. And I'm just going to spread those out so I can see a little bit better. No multiplicity on the roots, okay? There's no bounces, there's no bends. It's just going to go straight through. Third degree with the leading term that is positive. So it's going to start low and end high, and it has to go through each one. So it should look like this. Okay, should look like this. All right, now let's go to our calculator. And what do we got? X cubed minus 4x squared. So x cubed minus 4x squared. Oh, I didn't put an x in there. So x to the third power. That didn't work. Minus 4x squared. This is not working really well here. Minus, is that not showing up? 4. Okay, plus x plus 6. All right, graph. And window, zoom. I'm going to go back to standard window. Okay, so you can see where it hits, right? So it hits at -1, hits at 2, hits at 3. So we got 3 roots, we got a third degree function, and most it can hit the x-axis 3 times. All right, so now what I want you to do is take a look at this one. Now I want you to find all the rational zeros for this one right here. Now, what's going to be our first step? Okay.
Set it equal to 0.
Set it equal to 0. And then what? Where are you going with that?
Grouping.
Grouping? Might work. Interesting. Try it. So we're going to try grouping. But I don't know about that. Why am I a little hesitant on grouping? So 6x cubed, because you're trying to find the roots, right? Minus 7x plus 60. And if I group, the only thing I can pull out x squared, right? And then I get 6x minus 31. And do I have anything in common there? Second one. All right, so I'm kind of stuck. What can I do? Mia? You don't know? All right. Why can we do the other problem? Why is this other problem a little bit easier?
You gave us a root.
I gave you a root, right? I gave you a root. And the root, what was our root? 2. Do I have a root for this one? Am I going to give you one? No, that would be way too nice. How are we going to find the roots? You got to what? You got to guess. So like, you just got to guess. All right, so here's what I want everybody to pick a number, plug it in. And what are you looking for when you plug it in using synthetic substitution? What's a good thing that'll happen? Remainder 0. Everybody pick one number and try it. See if we can come up with a root. See if we can come up with a root. But don't just do one. I don't want you to waste too much time. Or you might not. Grace, you plugged it in? What'd you plug in?
I plugged in 5.
Seriously?
Yeah.
Good. What'd you get?
I got 0.
Okay. She plugged in 5. She got 0. So what's that mean? So anybody else get a 0? What'd you get?
I also did 5.
You also did 5, so you had the same one. All right, give me something that didn't work. Okay, let's just take a look. What'd you get, Cooper?
0.
0. All right, what'd you get when you plugged in 0?
60.
Okay, you get 60. All right, anybody plug in 1? No? Nobody? Anybody plug in 2? What'd you get?
Negative 30.
All right, good. This helps me right here. What can anybody tell me something from those 2 pieces of information? What has to be true?
It has to be between 0 and 2.
There has to be a root between 0 and 2. Why?
Because 60 is positive and 2 is negative.
Okay, so the point, it hits at 60 and it hits at negative 30. So somewhere between there, it has to cross over what? X-axis. Okay, so we know there's got to be a root between, if those are right, between 0 and 2. What theorem is that? Obviously, it's the what? Intermediate value theorem. Of course, right? All right, Cole, what'd you plug in?
I plugged in 4 and got negative 80.
You got 4 and you got negative 80. Anybody plug in 6? What'd you get, Gav?
198.
You got 198. Now this kind of confirms our theorem, right? Because we said 5 was a 0, right? So at negative 80 and 198, it has to occur somewhere between there. All right, so we did find a 0. It was 5. So what does that give me then? So now everybody use synthetic division. If you already did it with 5, you're good. And then, so that gives me 6, negative 31, negative 7, and 60. And then go ahead through there, and that gives me, go ahead and do your work. Make sure you get a 0. Okay, 6 times 5 is 30. Negative 1 times 5 is negative 5. Negative 12 times 5 is negative 60. Adds up to 0. So now f of x becomes x minus 5 times 6x squared minus x minus 12. What can I do with that 6x squared minus x minus 12? 2 things. You can factor it, or what else? Quadratic formula. It does factor. So take some time, go ahead and factor it. See what you come up with.
Because I like to do group. Well, I'm sorry.
Oh, I erased that. Okay, just go 0, 2. What do we get for f of 0? 60? F of 0 was 60. And f of 2 was negative 38?
Negative 30.
Negative 30. Okay. All right, so we're factoring this. So we get f of x equals x minus 5. And I believe this factors into 3x and 2x. And the last numbers have to multiply to 4 times 3 or multiply to 12. So 4 and 3. One of them has to be negative, one of them has to be positive. Let's see here. I think if we put plus 4 minus 3, double check me. Does that work? Okay, however you get there, that's got to be your answer. Now, what are our zeros? Now, I know most of you just do this all in your head, but here's what you're doing. You're doing x minus 5 equals 0. So x equals 5. I'm doing 3x plus 4 equals 0. Subtract 4, divide by 3. I get x equals negative 4/3. And then I get 2x minus 3 equals 0. Add 3. I get 3/2. Now we said before f of 0 was 60. We said f of 2 was negative 30. So there's got to be a 0 between those two. And as there is, it's 3/2. Would you have guessed that? I don't know. Would you have guessed negative 4/3? I don't know. There's got to be a better way. Okay, you can't just randomly just guess and hope you got it right. If it wasn't for Grace and Jacob, we'd still be here. Okay, but there is a way to figure this out. All right, now consider here is the original we started with, right? This is the factored form. Start with the factored form. And how do you get the leading, what would be the leading term of the expanded form? What do we have to multiply together to get the leading term? Okay, Jacob, is that question making sense?
Yeah.
So what do I multiply together to get the leading term?
The first two, or all three of them.
All I want to know is how do I get that 6x cubed? That's what I mean by that.
Oh, the first ones of all two factors.
The 3x, the 2x, and the x, right? What do those all multiply to give me? 6x cubed. All right, how do I multiply? What do I multiply together to get that last term? 60. Think about that. These three, what do I multiply together to get that last term? All right. Peyton, is that making sense? What do I multiply together?
4, -3, and +5.
Just the three constants. Now you can FOIL those and you can do all that other work and that's fine. But really, these are all I need to know. So these are my answers, right? The last part of these factors have to be a divisor of 60. 4 goes into 60, 3 goes into 60, 5 goes into 60. These three all have to be a divisor of 6x cubed because they multiply together to give me that. So we're going to use this fact. So that is 3x times 2x times x. This is 4 times -3 times -5. It's always going to be that way. So what we want to do is we don't want to just randomly guess because we'll be here all day if we randomly guess. So we're going to figure out a way to whittle our numbers down. There's still going to be a little bit of guessing involved, but it's not going to be nearly as bad. So right here, this number, and this number, these are the key numbers. They multiply to give me 60. This number, and this number multiply to give me 6x cubed. All right, now let's put this all together. It's called the rational zeros theorem. All right, copy that first part down. And then we'll kind of walk you through it, talk you through it. All right, and this is just the first part of it. So for a polynomial function with integer coefficients, you can't have fractions or radicals. If a is a divisor, the coefficient of the term of highest degree, that is your leading term, your 6x cubed. If a is a divisor, just sum 2, a 3, a 1. Okay, and b is a divisor of your constant term. Okay, then b over a, b divided by a, is a possible zero of the function. Possible. With a corresponding possible factor of ax minus b. Okay, so that's the one key thing. Possible zero, possible factor. All right, so think about this. If 3 over 2 is a possible zero, how does that become ax minus b? What's that going to look like?
2x minus 3.
So it'll be 2x minus 3 will be the factor. Okay, so then 2x minus 3 is a possible factor. All right, and then that's just a general. So just pay attention here. Don't worry about writing this all down. What if you have like -1/2? What would be the possible factor? Okay, -1/2 is the possible zero, the possible factor.
2x plus 1.
2x plus 1. Good, good. So it's going to be the opposite sign. Okay. What if you just have -4? What's the possible factor? Don't make that hard. We've already done that. It's just x plus 4. Okay? All right, now let's put this into a problem, because right now it probably doesn't make any sense. It doesn't make a lot of sense. Let's put this into a problem and see if we can put it all together. All right, copy that one down. All right, f of x equals x to the third plus 4x squared minus x minus 4. Now, when we did this last one, I just said just guess numbers. We don't want to do that because that's going to take forever. So we want to use this rational zeros theorem. All right, what are my a values? Okay, according to that theorem, what does it say it is possible divisors of what? Okay, a values. Peyton, back I see you read. It's possible divisors of what?
I can't find it.
Right here, let's see. A is a divisor of the coefficient of the term of highest degree. Now, what is our coefficient of x cubed? It's just a what? 1. What are the only numbers that divide into 1? It's just 1, but here's the key. You have to do plus or minus. You have to include positive, negative, okay? The b's are the divisors of 4, or -4. And it's going to be the positive and negative ones. So think about this. So we're looking at, hold on here, this -4. So the numbers that will go into that are 1, 2, and 4. All right, now what do I do here? Now I take b divided by a. Take b divided by a. Well, a is just 1. So you're taking 1 divided by 1, 2 divided by 1, and 4 divided by 1. So here's what we're left with. Plus or minus 1, plus or minus 2, plus or minus 4. Okay? All right, those are all the possible roots right there. That is it. That's all the possible roots. So how many numbers are actually there? There's 6 numbers. So we took it from an infinite, just randomly guessing, and we narrowed it down to what? 6 of them. How many of these could be roots? If it's x cubed, there could be a total of 3. All right. So now there is an element of guess and check. You just got to pick a number. So let's kind of all stay on the same page. Emily, pick one to try. All right, -2. Let's do -2. Let's plug it in. Let's see if it's a root. So -2, and I plug it in using synthetic division with 1, 4. -1, -4. All right, go through that. Let's see what we get. If we don't get a 0, at least we know what you get when you plug in -2. Ryan, is it a 0?
No.
No, you're kidding me. 2 times a -2 is -4, -5, 10. I got +6. All right, so no, it's not a 0. All right, so we eliminated 1. Kayla, give me another one. +4. All right, let's plug in 4. Let's see if it works. And I got 1, 4, -1, -4. 1, 4, 8. Not looking good. What's 31 times 4? 124. Is it 124? 124 minus 4. All right, and then that's 120. So, all right, 0 for 2. Who's next? Josh?
+1.
+1, he says. All right, so let's try +1. So +1, and I got 1, 4, -1, -4. And we got a match. Okay, so now once you get that, we can write it in the factored form. So if 1 is a root, that means x minus 1 is a factor. So that means f of x now equals x minus 1 times x squared plus 5x plus 4. And now what can we do with that, the quadratic? We can factor it. So go ahead and factor it and see what you come up with. And then that's going to factor into f of x equals x minus 1 and x plus 1 and x plus 4. So my zeros are going to equal 1, negative 1, and negative 4. Okay, 1, negative 1, and negative 4. All right, you good there? All right, let's take a look at this case here. And as you just look at it, how is it different than the last one? There's one main difference. What's the power? 4th degree. All right, so we want to make sure we don't make a mistake there. All right, so go ahead and copy that down, and then we'll look at the possible zeros in a second. Now the coefficient here is just a 1. So I want you to think if you can list the possible zeros. Think if you kind of got that yet, or if you're not sure, just hold on a second and then we'll get to it. Let's see if you can list the possible zeros. Now your A value always divides the coefficient, so the highest degree. So it divides, it's just a 1. So they were both just a 1. So A is plus or minus 1. Now all the divisors of negative 18, it doesn't matter about any of those other numbers, just the first and the last. That's all we really care about. And those divisors are 1, 1 goes into 18, 2, 3, 6, 9, and 18. Okay, 1, 2, 3, 6, 9, and 18. Now, the possible zeros, they all won't work. Will be of the form B over A. They could B divided by A. Well, A is just 1. So really, we're just left with all those constants. So all our possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, 6, 9, 18. 2, 4, 6, 8, 10, 12 numbers, right? 12 numbers. So we took it down from an infinite amount to 12. All right, you pick 2, see if you can come up with a root. If you don't get a root within 2, then just stop. If you get a root, then just wait. And what I said, when you get a root, you get a 0. What's that? Oh, third one. Okay. I thought you were after you got the 5.
No, I just kept erasing.
Okay. Not as impressive now. So just plug in. If you plug in one that doesn't work, plug in another one. If you get 2 that don't work, just wait. And if you can use the intermediate value theorem, then that'll be nice. Grace, did you come up with the root again?
No.
What? No? Adam, did you get a root?
Yeah.
What'd you get?
3.
All right, 3's a root. Okay, I'm sure that you got others that didn't work. That's fine, but 3's a root. So if you didn't get 3, start with that. And so we got 3, and then we start with all your coefficients. 1, negative 6, negative 7, 54, and negative 18. And so I got 0 here, and I got 1 times 3. Negative 3 times 3 is negative 9. Negative 16. Negative 16 times 3 is negative 48. 6 times 3 is 18. We get 0. So we get 0. All right, how many other roots are there? Could there be? We got 1. It's a 4th degree, so that means there's how many more out there, Cole? 3. There's 3 more out there. What you have to do is you don't want to go back to the original one. Okay, here's what we need to do. We need to start with this case here. And some of you will just start right here, but I want to make sure you understand what's going on. Since 3 is a root, that means x minus 3 is a factor times x cubed minus 3x squared minus 16x plus 6. We want to do synthetic division on this cubic now, just like we did the other problems. Well, what's its last term? It's just a 6, right? And this is a 1, so that kind of reduces my possible roots. We just need to find divisors of 6. 1, 2, 3, or 6, so we don't need to try 9 or 18. Now, before you go any further, does anybody know what the root is?
-3.
Okay, negative 3 also works. So if you started with negative 3, now you can use 3 in the next one. Okay, so now here's what you want to do. Take negative 3 into 1, negative 3, negative 16, and 6. Okay, go ahead and do the synthetic division. You can't go back to the original problem because we need to keep knocking down the degree until we get it to the 2nd degree. And if you keep going back to the original one, we'll never do that. So 1 times negative 3 is negative 3. Add together, get negative 6. 18. 2 times negative 3 is negative 6. All right, so where are we at now? Negative 3 is a root. So my function, my original function, is x minus 3 times x plus 3 times this polynomial down here, x squared minus 6x plus 2. All right, once you got it to that point, what do we do with that x squared minus 6x plus 2? Well, what do you hope to do? You hope to factor it. But if it doesn't factor, then what do? Quadratic formula. Yeah. All right, do the quadratic formula on it, because it doesn't factor. And then when you are all done, when you find that, I want you to go and I want you to graph it on your calculator, the original function. Go graph the original function on your calculator and verify those points. All right, see what you come up with. Now you can help each other out now to make sure you're kind of on the right track. Whoever you're sitting beside. Let me see what, if you got the square roots. Let's take a quick look. All right, keep going there. Let me see what you get for your radicals once you're done here.
Yes, before that, let's double check that.
Yeah, because, hold on, let me move that down. Okay. The b squared should be 36. B squared minus 4 is. Okay, b squared minus. Okay, that 3 goes with that. The negative 2, okay, plus. Well, I yeah. So it could be. Yes, yeah, try something. Guys.
B squared minus 4AC.
Yeah, so b squared. Okay, what's that?
3 plus minus 7.
So is it like, alright.
Mine's a little, I got it.
No, it's minus, you multiply those all together. So it should be 36 minus 8. Because you multiply those, it's 20. Alright, we get. Okay. And now, what happened to the 2? Can't cancel that, remember you gotta cancel all 3. You gotta cancel all 3, so that's what happens. Alright, what do we get? Okay, good. Did you graph it? Graph it. Go ahead and graph it. What do you get? Okay, graph it? Okay. Alright, what do you get? Alright, good. Graph it? Yep. Alright. Change your window so I can see the whole thing. See if you can do that. Okay.
Yeah, and when I originally did it, I did 1 and -1, and it was positive and a negative, so the 3 minus the 7 got the irrational value in there.
So it has to hit between them.
Yeah, so it's got the irrational, okay.
It just has to hit. Yep. So, 2 radical 7. Alright, what do you got? Alright, good. Did you graph it? Okay, and check the decimals. Check the decimals for that one. Alright, Gavin, you got it all? Alright, it's ready. Where you at? Okay, that 2 has to cancel with both of them. So it becomes 3 plus or minus the square root of 7. That 2 shouldn't be there. You cannot just do 6 divided by 2, and then it's gone. That 2 has to be divided by 2. Yeah, but where'd that 2 go? No. Here's what you gotta think of it as. Think of it as 6 over 2. See, I can break this up into this. Do you agree with this? And then 6 over 2 is 3, but what's 2 over 2? That should be your final answer. Because this 2 has to divide into both of those, not just one of them. So make that your final answer. Okay, what do you get? All right, good. You got a graph?
I'm looking at it.
All right, x equals negative b. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And then when we're substituting in, b is negative 6, so the opposite of that is 6, plus or minus square root. All right, 6 squared, 36. So negative 6 squared, 36 minus 4 times a is 1, c is 2, over 2 times 1, which is 2. I get 6 plus or minus square root. All right, what does this become? 36 minus what? 8, which is 28. You got to get 28 in here, divided by 2. Square root of 28 reduces to 2 radical 7. So I got 6 plus or minus 2 square root of 7 over 2. When you cancel, remember that 2 in the bottom has to go to both things in the top, and that becomes 3 plus or minus square root of 7. All right, so my zeros are, hold on here. -3 from earlier, 3 from earlier, and what do I get for this one? I get 3 plus square root of 7 and 3 minus square root of 7. Yes, you can write it as 3 plus or minus. It's not a big deal. Now, I asked you to graph it. So I got this here. I'm not sure what my window is. Let me go to Zoom 6. Okay, 3 plus square root of 7. Okay, that's a number. What number is that? 3 plus square root of 7. It's 5.65. Okay, that's where it's got to hit. So if you take a look at your graph, right there, that's 1, 2, 3, 4, 5. That's 5.65. Now let me make my window a little bit nicer. Adam Lippy, what do I got to go make my Y min and Y max?
I made my Y min -200 and then my Y max 1000, and I did it on a scale of 100.
All right, so let's see here if that's going to show the whole picture. So it crosses up. Whoa, you went way up there. I don't need to go up to 1,000. I'm gonna go down a little bit. You all right with that?
Yep.
Okay. And let's see, will that work? 200. Okay, and Cooper, tell us what you found out. What did you tell me?
Originally, when I had gone through, I did 1 and -1, and I got a positive number and a negative number, so I knew that there must have been an irrational root between.
What'd you get for 1?
For 1, I got 24.
And what'd you get for -1?
-36.
Okay, now you can never find those irrational roots by these zeros. These zeros are only rational roots, so you have to break it down to get it to a quadratic. Okay, otherwise you will never find them. Okay, they're there, but you cannot. They're not in this list, obviously, and they'll never will be in that list. So you just got to be careful. All right, we're not going to have time for that one. I want you to do just a couple, just to understand what's going on. I'm going to have to do a little bit more tomorrow. So for page 373. But understand those irrational roots. They hit the axis. Sometimes people kind of think, well, no, they don't. But yes, they do. They just hit it in a decimal. Okay, make sure you understand that.